Primo is a program that takes an input file with the name of the form myfile.in or yourfile.in, something like that. You decide on the file name. You put the number you want to test into the file, in this case 29, 11, 13. That's quite a lot smaller than the numbers you'll want to try, but it serves a purpose for this description. It's called a candidate because before it's been tested we don't actually know if it's prime or not. Primo takes the input file and starts to find out if it can be divided by any numbers other than 1 and itself. When it's got a result, it creates an output file which will have a name of the form xyz.out or abc.out, something along those lines. You can't control this file name. Primo decides on the file name for you. If you open the file and have a peek inside, there'll be a section called status, and if the number proved to be a prime, it'll say candidate certified prime. Congratulations, you just found a prime number. It uses a little cryptography here as well. It includes the number you tested in a section called candidate. There's a line that says $n equals and then the number. It might not look like the number you tested, but it is. That's because it's expressed in hexadecimal, otherwise known as base 16. That's just a natural number system for computers to use. 29, 11, 13 expressed in hexadecimal notation is 47129. Below that in the file there is a section for a thing called a signature. It just looks like a couple of long complicated numbers, but the way to look at it is as if Primo is a person and they have literally taken a pen to the document and signed it. It's like as if Primo is saying, I verify this number is genuinely prime and here's my signature to prove I've checked it. Now the reason this is useful is because Primo can also be used to verify other people's output files. Verifying an output file takes the tiniest fraction of time that running a full prime calculation would. If Bob sent you his output file and you wanted to be sure he found a prime number, well, Primo can take a look at the file and its signature and either say, yes, it's genuine, or nope, either the file has been corrupted, or, more sinister, somebody has tampered with it and tried to edit the contents to make things look better than they really are. Could it have been Bob himself? Surely not. Primo includes a verification algorithm which takes the prime number. Well, actually, it takes a lot more information than just the prime, but let's keep things simple. It takes the prime number and the signature and sees if they match up to each other. If they do, that's great. You get a signature is valid message. But let's say somebody evil just simply edited the output file before it got to you. When you use Primo to validate it, the algorithm spots the inconsistency. In this case, the criminal has made a schoolboy error and edited the candidate number to make it slightly larger. The only problem is that he's turned it into an even number. So Primo says, error, invalid signature, and error, even number. Let's imagine he now makes another edit. This time when Primo checks the file, it just says, error, invalid signature. This is what us organizers at the Prime Challenge will do with the primes you send us. Your numbers are only candidate primes until they've been validated. The fastest way to get them validated is to send a Primo output file when you submit your prime to the challenge. Let's imagine you test a certain number. In this case, we'll use 29, 11, 17 as an example. In reality, your number will be much bigger than this. Primo tells you the number is not a prime, so you move on to test another number, in this case 29, 11, 13. Primo certifies it as a prime number. The .out file will contain a hexadecimal representation of your number and the signature. So when you send the file to us at the Prime Challenge, we'll get Primo to validate the signature in the file. It will pass the validation, which will mean your prime number is validated by the Prime Challenge fairly quickly. Your entry in the results table will have your name up in lights and the status will have changed from candidate to verified. Congratulations, you're now leading the table. Let's now imagine an evil witch casts a spell on you that makes you want to cheat to ensure the continued glory of that coveted leader position in the results table. Imagine if you took the output file that you know already worked and simply edited the number to make it bigger. Let's say you went for 299991. When the file is presented to Primo at the prime challenge back here to verify the signature, it'll come back with error, invalid signature. If you aren't using Primo to find primes, say if you're using your own code and your own algorithm, you can just send us the number in a file. It will take longer for us to validate the number is prime because we'll have to do a full check. If you're curious about how prime signatures work, or rather I should say, if you're curious about how signatures work, watch the CryptoPrimer video at http://aka.ms/CryptoPrimer. There are a few things you're interested on your desktop for Primo. One is this icon is the same as this one. If you click either of them, then Primo is launched. So let's try the launch bar. This is Primo. This is the primality proving program. Another tool you'll want to use is the file system. So let's click that. And in particular, in Documents, there are some folders which are useful. Okay, so in order to use Primo then, do you remember from the video, from the first part of this video, the first thing that was needed was an input file. Now my recommendation is that you create a new folder in your file system. Let's call it something like primes on the 20th of the 11th 2013. So these are all the primes that I'm going to test on today. And now let's create a file. So in order to get an input file, Primo has to create one. So I go Menu, New Input File. So I can now work my way into that folder. So I go Documents, Primes 2011-13, and it's going to create a file for me called new.in. Okay, now I don't like the name new, so I'm going to give it something a bit more meaningful, which is the 20th of the 11th 13-1, which is my first attempt at generating a prime number. Okay, so I click Save. And now it opens up the file for me in a text editor, and there's the candidate that I was telling you about, n equals. So let's try a number that's known not to be prime, 291117. I know that's not a prime number, but we're just going to go through the process of seeing what happens. Okay, I'll save this, and then in Primo, I need to get it to check that file with that number in it. So it's the certification tab, and because the file itself, because the number is less than 2000 digits, that's 2000 decimal digits, I select that, it automatically selects 23 bits, and I build the filter for checking the number. Next I load the file into Primo. So load, it's in Documents, Primes 2011-13, there's the file. So I click that, open it, and a work report opens up, and what it says is the candidate is divisible by 3. If it's divisible by 3, it's not a prime number. So, as a result of that, let's go in here and have a look. There's a work report file, but there's no .out file because there's nothing to certify. It's not a prime number, so there's no great news. Okay, so I'm going to delete this work file because it's of no use. And then I'm going to modify this file. So this time I'm going to make it into a prime number. So 291113 is a prime number. I'm going to save that. Close this down. And then we'll do another certification. So again, I do load. The filter's already built because it's 2000 decimal digits, which means it's a 23-bit filter. I click load, and then I click the file. I open it. And it says this time that the number is certified as a prime number. That's great. So that is a prime number. Now you can see we get a couple of files that are not interesting for us. So I could actually delete those files. They are interesting for some people, but not for us in this example. Why is that not selecting? Let me do it like that and move to trash. But the file I am interested in is this one, the .out file. So if I open this file up and have a look at it, it says in here that the candidate is certified as a prime number. We know that. What's the candidate though? Well, the candidate is the number that we put in the first place. Let's find it. There's lots of information in here about the candidate, but the thing I'm interested in is this bit here. This is the actual number itself. Now you may look at that and say, well, surely the number is 291113, and that's true. It's just an awkward quirk that Primo's output file tells us what the number is in hexadecimal. So how can I convert that? Well, if I go to the terminal and fire it up and then type calc, I can now say base 16, and that means we're working in hexadecimal now. It's just base 16. I can type in 47129, and sorry, I could say base 10, which is decimal. I can now type in 291113. If I now type base 16 and type 291113, it tells me what it is in hexadecimal. I hope that makes sense. So it tells me what 291113 is in hexadecimal. It's 47129, and that's the number that we're looking at in this thing here, 47129. Okay, great. And it also has at the bottom of the file the signature. So this is a little bit like Primo physically as if Primo is a person, physically signed a piece of paper to say, I certify that this number 47129 in decimal, which is 2 in hexadecimal, which is 291113 in decimal, is certified as a prime number. So how do we check that certification? Well, when you send the output file to the prime challenge, you register and you enter your number into the results, then somebody at the prime challenge will go like this. They'll go to verification and they will load your file. So there it is. Let's load that file. And what does it say? It says that the file has a valid signature. So that means that the file hasn't been modified between the time that Primo created it and a different copy of Primo checked it. Okay, let's have a look what would happen if it was modified. So let's go back to this file and let's modify it to say that let's imagine that the number that we're going to check is 29991. So let's fire up our terminal again. So if I say 29991 in hexadecimal, sorry, it's 299991. That's the number that we gave in the earlier example. So in hexadecimal, that's 493D7. Okay, let's go back to the file, the out file, and let's change that number there to 493D7. 493D7 and save it. Okay, so at the moment it looks as though we've got a good signature on a file which is validating that 493D7, otherwise known as 299991 in decimal, is a prime number, because up here, let's get the up here it says that it's certified as a prime, so it appears to be certified. So if we save this and close it down, let's imagine that this file was sent to the people at the prime challenge and we went through the verification process. Then what we would do is we would load that file into the verifier. There it is. We'd open it and it would come back with an invalid signature. So we therefore know that we would know to just simply ignore this file. So we can always check that a file is a valid number. So what you'll probably do is check very large numbers by modifying the input file. Let's have a look at the input file again. So I could put an even bigger number into this. I'm just randomly picking a very large number. Let's go for a few more digits. That's no good because it's an even number. Let's put a 3 on the end. That's an odd number, which means it's a prime candidate. Save the file. And let's go through the certification process once more. So I can load this up, load the input file, and you can see very quickly it came back with the candidate is divisible by 3, another number that's divisible by 3. So that's not a prime number. Okay, so you will just keep doing this with bigger and bigger and bigger numbers until you find a number that comes up and says this is certified as a prime number. And then what you'll do is take the resulting output file, this one, and send it to the prime challenge as part of your prime, to enter a prime number into the challenge. Now, you may want to use some features in the Primo program, which means you don't have to type really large numbers. So, for example, one of the things you might want to do is say that you'd like to check a number, rather than being of that form, it is something like 2 to the power of 293 minus 1. Okay, so should we try that? Let's save it. Let's go through certification again. I'm not sure how many digits that is, but I think it's less than 2,000 digits. So let's load it up. Let's open it. And what does it say? It says the candidate is not a Lucas-Strong pseudoprime for p equals 1, q equals 2. So this is not a prime number. It's not certified as a prime number. Now, the thing is, you might want to know what that number actually looks like in longhand. And again, you can use Primo to help you with that. So if I say that we're working in base 10, and I say 2 to the power of, was it 291? I can't remember what the number was. 293. 2 to the power of 293 minus 1, and hit return. That's what it is as a big long number. Okay, so you'll find that a lot of prime numbers are expressed in this way, 2 to the power of something or other, minus 1 or plus 1. And there are a lot of other notations as well. My recommendation is actually that you just use this very large number. It makes it very easy to compare numbers when this is done. But the calc program will work for absolutely huge numbers. So this is a program which is designed to do enormously large integer arithmetic. Okay, I hope that's given you a clue of how you use Primo to generate prime numbers. I suspect that when you put some of the numbers in that you'll be dealing with, it will take a lot longer than what it's just taken me. So let's just do that. Let's put a big number in there and see what happens. I won't close that terminal, but I'll go to this file. Let's just say what happens when we add another digit onto the end of that. So 2 to the power of 2935 minus 1. Save that. Let's go to certification. Load it up and say open. It did that quite quickly. Divisible by 31, so it's not a prime number. Let's try a bigger number again. How about 29357? Save that. Do the certification again. Load it. There's the number. Okay, so you can see it took a few seconds that time. It's still quite a large number though. The candidate is not strong pseudoprime to the base 2. Okay, so that's not a prime number. What we could do though is take that number. Let's copy that. Let's go here. Let's paste it and hit the return key. And you can see, you get some idea now of how big this number actually is. Look, it's absolutely huge. Okay. And Primo was able to calculate that wasn't a prime number in a relatively short time, probably less than 4 seconds. So you can deal with very, very, very large numbers. The largest prime ever calculated is 17.425 million digits. That one did take a few years to calculate though, so you're not going to get that high. But remember, below those huge numbers there are lots of lost primes. There are lots of gaps in the number space that haven't been explored yet, and you might be the one that finds the highest number in that unexplored space of all the people that are taking part in the Prime Challenge. Good luck, I hope it's you.